Hi, today I'll show you how you can implement your own retrieval augmented generation system with very little code thanks to Google Cloud RAG Engine. This is a new addition to the Vertex AI SDK that allows you to use no boilerplate, idiomatic code to manage your data stores and configure retrieval. I'm going to use Google Drive as my data source, but local files and Google Cloud Storage are also supported, as well as external data connectors for Slack and Jira. This diagram illustrates the architecture of a retrieval augmented generation system. The first step involves chunking the data, generating embeddings for these chunks, and storing the embedded chunks in vector database. During inference, a user submits a query, which is first embedded with the same embedding model, and the top k relevant chunks are retrieved using vector similarity search. The corresponding natural language content of these retrieved embeddings is then fetched and used as context, appended to user's query, to form a structured prompt for the language model. I have a Google Drive folder here with a single PDF file. You can upload file in various formats like HTML, JSON, Markdown, PowerPoint and TXT, and it will work just fine. What we need now is to share this folder with the RAG Engine service account. We can find its email in IAM by checking this checkbox and searching for Vertex AI RAG Data Service Agent. Let's copy that and give it a viewer permission on our folder. We also need to copy the folder ID as we will need it in the next steps. Once that is done, we can implement our Python script. We only need a single Google Cloud Vertex AI library. Make sure to install it in your virtual environment. We need to set our project ID and region, and then paste the folder ID here. The embedding model we choose is the newest text embedding 004, and it needs to be provided in the following format. For the LLM, I will specify Gemini Flash. Let's initialize the Vertex platform with our project and create an embedding model config. This piece of code is responsible for creating an empty data corpus to which we will import our data. When we print this object, we can see the full ID of the resource in Google Cloud, the name that we gave, and the embedding model. Now we can import files by providing a path to our folder in the following format. The chunk size and overlap parameters control how the documents are divided into smaller chunks, how many characters a single chunk can contain, and how many characters should overlap between two adjacent chunks. At this point, we have our RAG store ready, and we can query for chunks similar to the provided text. But to complete this RAG, we would like the LLM to automatically use the knowledge from our Google Drive when we ask a question and generate the so-called grounded responses. For that, we can create a retrieval tool and give it to the LLM to use. This store contains the configuration for chunks retrieval. Top k similar specifies how many similar chunks to use. The distance threshold specifies how similar a chunk must be to be considered. A smaller distance means more similarity. Now we define the tool and instantiate the LLM. We can also pass the Vertex endpoint here if we want to use our self-deployed model. If you're interested in deploying an open source Gemma tool on Google Cloud, check out my previous tutorial. Now we can ask our Drive data. And it generated a nice, relevant answer. We can also see which chunks were passed to the model as context. This allows us to verify if we like the output, and if needed, we can adjust our chunking or retrieval configuration and try again. When I ask a question that is completely unrelated to my data, I should get a generic "I don't know" answer. Let's try that. And this is exactly what happens.